This video is on the lateral and surface area of cones and pyramids. So first of all, a cone is like an ice cream cone. The description of it is that it has one circle base, it has a vertex, and then it has a slant. The lateral area is pi times the radius, and this lowercase l is the slant. The surface area is pi times r, or radius, times the slant plus pi r squared. Now if you notice, this is very similar to the prisms and cylinders that we did. The first part of the surface area formula comes directly from the lateral area, and the pi r squared comes from the area of one circle. Thinking about an ice cream cone, the top part is one circle, and then you have the bottom portion. A pyramid, again, has one base, and then the bases intersect at one vertex. The lateral area is 1/2. Here's our capital P again, that's perimeter. This is only perimeter of the base, and then our lowercase l, which is the slant. Our surface area is 1/2 perimeter times the slant plus, notice our capital B, that's the area of the base. So I just added a couple notes on here. This capital P is for perimeter of the base. The lowercase l again is for the slant, and then this capital B is the area of the base. So depending on what the shape is would determine how we figure that area of the base out. Here are our first couple of examples to work with. So here is our cone, and our formula for the lateral area is lateral area equals pi times radius times the slant. So if you look at the cone here, the radius is found up here on the circle part of the cone. So our radius would be 6. We can see 6 there. So we would take pi times 6 times the slant. Notice here in this cone you have this piece labeled 21, and then you have this piece down the center. Just like from chapter 10, the 90-degree angle right there comes from the height. So this dotted line that's on the inside of the cone, that's the height. Okay, so this would be the height here. The outside, the slanted part labeled 21, that has to be the slant. So when you are finding lateral area, you want to make sure you use the slant and not the height. So we are going to multiply the pi times 6 by 21. So we have 21 times 6 times pi, and our answer for that would be 126 pi. And that's our lateral area. And since we are still finding area, it would still be units squared. So our surface area is just our lateral area, so that's around the cone, the area around the cone, which we figured out to be 126 pi. Plus pi r squared. And just like we did in chapter 10, if I were to just find the area of this circle, it would be pi r squared. So for this circle, that's pi 6 squared. So I could put pi times 6 squared, and we know that that would be 36 pi. So we have 126 pi plus 36 pi. Now, just like combining like terms, both have pi in it, so we can just combine those two to get 162 pi. And we know that we're still finding area, so that would be units squared, is what my answer would be there. So now if we take a look over here, this is a pyramid. A couple of things about a pyramid. A pyramid only has one base. So if you go back to the last section that we did, we worked with a prism. And a prism had two bases. So a pyramid has only one base. Now this base can be any shape. Right now we have a triangle for a base, but this base could be a polygon, it could be a square, it could be a rhombus, it could be any trapezoid, any shape. And then it comes together at one vertex. See, right here is the vertex. So down here at the bottom would be considered your vertex here. So the lateral area would be 1/2 times capital P. Remember what I said on the other page, the perimeter, you only look at the base. So in this case, our base is a triangle. So if I'm going to find my perimeter, I'm going to take 5 plus 12 plus 13, so that's 30. So I'd have 1/2 times 30. And then again, my slant comes in. The vertex and goes down, here's the vertex, and goes down the side of an object. So notice this dotted line right here ends right here. So this has to be the slant right here, which is 20 because it ends right there. Again, think about the height. The height is the thing that has to make 90 degrees. So right here, you can see my 90-degree angle up there. Right here would have to be my height, and this would be my slant. And it goes to the center of the base, which is what we found there. So if we multiply 1/2 times 30 times 20, which is my slant, we get 300. We are not dealing with circles, so we are not going to have pi involved, but it is area, so it would be units squared. So we'd have 300 units squared. For surface area, again, the first part of the formula comes from the lateral area. So we're going to take 300 plus, and the capital B is the area of our base. Now, the way you figure out our capital B can change depending on what the shape of your base is. Our capital B right now is a triangle. And in order to find the area of a triangle, I would take 1/2 times base times height. So in order for me to figure out my capital B, I only look at the base. So this little triangle up here is my base. And I'm looking for my capital B, so my height is 5 and my base is 12. So I would take 1/2 times 5 times 12. So half of 12 is 6, and 6 times 5 is 30. So my capital B is 30. So I would take 300 plus 30, and that would equal 330, and since we're finding area, units squared is what my surface area would be. So here you can see those all labeled. Now, a couple of things just to point out on the next two examples here. Similar to Chapter 10, you may come across some pictures where you don't have the measurements you need. For example, in this cone right here, if I want to do my lateral area, I need to take pi times radius times the slant. Well, in this case right here, I have my radius, which is 8, but the slant is not 15. This 15 to this dotted line right here is my height. I need to figure out my lateral area, so you would have to do Pythagorean theorem with the 8 and the 15 to figure out what your slant is, which would be right here. So go ahead and figure that out now. So you can see here when we use Pythagorean theorem, this is what we come up with. Your slant would be 17, and once you find that, you can plug it into your formula for lateral area, which would be pi times r, which is 8, times your 17 to figure out your lateral area. This next example is a pyramid, and it has a vertex and it has a base. In this case, the shape of the base is a regular polygon, so in order for you to figure out the lateral area, you'd need to take 1/2 times the perimeter times the slant. So again, perimeter comes from your base. So this base right here is a regular polygon with one side as 6. So my perimeter is going to be 6 times 1, 2, 3, 4, 5. So your perimeter is going to be 6 times 5, which is 30. So 1/2 times 30. So your capital P would be 30. And again, your slant comes from the vertex and goes down the side. So right here would be your slant. So we'd say times 13. Remember that your slant has to go down, and at the top here, if it's this dotted line coming down, that's going to be your height, creating that 90-degree angle there. So don't confuse those two. When we multiply those together, we're going to get 195 inches squared, because we're still finding area. Then your surface area is going to be the 195 plus the capital B, which in this case our capital B is our base. Our base is a polygon, regular polygon. In order to find the area of that, you have to do 1/2 times the apothem. So 1/2 times the apothem, which in this case is 4.1. We can see right up here, 4.1 times the perimeter again, which we figured out to be 30. So our final surface area should be, once we take all these, 4.1 times 30 equals 256.5 units squared. All right, so that's how we calculate lateral area and surface area for cones and pyramids.